Hello everyone. In this video we're going to see the solution to this problem. If n is a perfect square and its second last digit is 7, what are the possibilities for the last digit of n, and can you show this will always be the case? So the way we're going to do this is we're going to let x be equal to 10m plus k, where m and k are both integers between 0 and 9. Because the problem is interested in the last and second last digit of our numbers, we're really only concerned with values of all of our concerned integers mod 100, and so we only need to consider initial values of the number mod 100. We'll let n be equal to x squared, which if we expand is equal to 100m squared plus 10 times 2 times m times k plus k squared. The reason I've written it like this is because we're concerned with the last and second last digit of our number. So I've written this out almost like a base 10 expansion where I have 100, 10, and then whatever is left over here. But what we need to sort of take into account now is the fact that k squared might be greater than or equal to 10, meaning there will be some carryover into the tens digit. And the way we're going to do this is by breaking it up into all the possible values of k as individual cases. The easiest one to consider are the values of k where k squared is less than 10. Those are 0, 1, 2, and 3. In that case, and to be clear about what's going on here, this also itself may not be the second last digit of x squared, because this number itself could also be greater than 10. But what we're really concerned with here is the last digit of this number, okay? So the last digit of 2mk can't be 7. All right, so if k is 0, 1, 2, or 3, then the square number that I'm interested in, or the square number I'm looking at, can't possibly have a second last digit of 7. Let's move on to the next case. This is when k is equal to 4. Then what I have is x squared is equal to 100m squared plus 10 times 8m plus 16. So k squared is now equal to 16. But I want to write this as if it's a base 10 expansion. So I'm going to shift the tens digit of this last thing, this 1, I'm going to shift it into here, like this. And I need the last digit of this quantity to be equal to a 7. And what does this mean for the possible values of m? M is going to be equal to 2 or 7. If m is equal to 2, then this is equal to 17. If m is equal to 7, then this is equal to 57. Okay, so we found two possible examples so far of the pair m and k. Our original number can be either 24 or 74. And when we square those, both of them end with a 76. Case 3 is actually going to be when k is equal to 6. We're skipping k equals 5 for the moment. We'll come back to that in a little bit later. Now, I have x squared is equal to 100m squared plus 10 times 2 times m times 6 plus 36. And if I do some algebra on this, I have 10 times 12m plus 3 plus 6. And again, what I'm looking for here are values of m where the last digit of this quantity is equal to 7. And this gives us m is equal to 2 or 7. If m is equal to 2, 2 times m is 24, plus 3, and I get 27. If m is equal to 7, 12 times m is 84, and I add 3, I get 87. Okay, so the other two other possibilities of our original number are 26 or 76. When I square both of those, the second last digit will be a 7. In the last case, our values of k equal to 5, 7, 8, and 9. Maybe you can see where this is going. But if I expand this, I get 10 times 2 times m times k plus k squared. And you could substitute each of these individually into here and take the tens digit and carry it up into here. But what's going to happen? Well, look at the squares of all of these numbers. The squares of all these numbers have a tens digit which is even. And so when you take the tens digit of k squared and bring it into this term here, you're always going to have an even number here. So 2mk plus the tens digit of k squared is even. And so this means that the tens digit of x squared in this case can never be a 7 because 7 is odd. And so there are no values of m and k where k is one of these four numbers that gives us the tens digit of our square number equal to 7. And so we've exhausted our list. The original number x has to be equal to 24, 26, 74, or 76. These are the only integers between 0 and 99 such that when you square them, the second last digit is a 7. And not only that, if you take each of these numbers and square them, the last digit is always 6. And that's the answer to the question. If you want to see how I came up with this solution, check out the process video, which is linked here. Thanks for watching.